Hello everyone. I hope you all are doing good. This is Lakshmi Narayana, Senior Physics Faculty. Today we're gonna discuss one of the important chapter in physics. Before starting the section, if you have any doubts, you can ask in comment section or chat box. Okay, we are on time. Let's wait for a few more seconds to others join the live section. Okay. So how are you all? You are good? Doing good, studying good, everything good, and the section also will be going to good only. Okay, yeah. So without any delay, can we start our session? Once again, welcome to you all for live section. Okay, if you have any doubts, you can ask or comment in the chat box. Okay, yeah. Now, the second section of light is refraction. Okay, so you all know what is refraction. Okay, what is reflection, refraction, rectilinear propagation of light. So these all are what? It's a properties of light. Okay, light transfers in single medium. Okay, go from one place to another place. How it will be? It's very straight. Okay, it's a very straight path. How we release an arrow. Okay, so like light also will go in a straight path. And coming to the refraction, in the refraction, this is the topics we're gonna cover in today class. Okay, what are the topics are there? See once what topics are there we're gonna discuss in today class. What are they? Refraction of light. Okay, and laws of refraction. So refraction of light means what is mean by the refraction of light. In refraction, what are the laws are there? Okay, and then after refractive index, then after refractive index, and refraction by spherical lenses. Okay, if you use lenses, how the refraction will be? How the, if you are using any object or any obstacle or any transparent material, how the refraction takes place? Okay, so here refraction of spherical lenses. Next, lens formula. Next, lens formula. So we are taking a lens for see the objects and things, right? So here we will discuss about lens formula and then after power of lens. So if the person is having any defect, they will use spectacles, right? Which type of lens they will prefer? How they will calculate that which defect it is there and what type of power they have to use? Lens, we go with the power. Okay, everybody have same power. Some persons can see long distances, some persons cannot see short distances, some persons can see short distances, some persons cannot see long distances. For these two people, can we use same lens, same kind of lens? No. So how can we decide? It depends upon power. Okay, yeah, can we go to the topic? Look at the topic. Light travels in a straight line. Light travels in a straight path. Light always travels in a straight path. Why? Light travels in a straight path. Okay, when it travels light in a straight path, whenever light in a one medium, okay, actually there is no required of medium. Okay, if I want to go from one place to another place, what is required? A transport is required. Actually, for the light, no need of any medium. No need of any medium. So, if light travels in one medium, light travels in one medium, how the light will be? Straight path. If light travels only in air, it straight path. Only in water, it's straight path. So if you take any one medium, in that one medium, how the light will be? Straight path. Okay. Next, coming to the next point, when light passes obliquely from one medium to another. Remember the point, one medium to another medium. Okay, one medium to another medium. For example, I am taking it two mediums here. One is air and other one is the water. One is air, other one is water. Two are two different mediums. Okay, here I am taking a surface. This is a surface. It's a boundary of these two surfaces. This boundary is separating air. This boundary is separating air and as well as water. Whenever light traveling from either air to either air to water, what happened, two different mediums are there. How the behavior of light here, how the behavior, the light takes place bending. When the light bends, whenever light travel from one medium to other medium, the refraction takes place. Remember what is mean by refraction? The refraction is nothing but bending of light. What is meant by refraction? Refraction is nothing but bending of light. When a light takes place bending, whenever travels from one medium to another medium, light travel from one medium to another medium, it takes place bending. Okay, that property we call it is that refraction of light. What is the refraction of light? Whenever light travel from one medium to another medium, refraction takes place. See, whenever light traveling from air to water, what happen? Just to draw the normal. Normal is what? It is an imaginary ray. It is an imaginary ray. It always perpendicular to the surface. Okay, it is an imaginary ray. It always perpendicular. That means how much angle? With how much angle it is there? 90 degrees with the surface. See, here we take in a normal. Whenever air to water, light traveling, what happens? See, this is the actual direction of light ray. Okay, air we call it is the rarer medium and water we call it is that denser medium. Here you have a confusion about what is rarer and what is denser. Rarer medium means where the light go fast. Okay, in which medium light go fast, it is called rarer medium. Where the light goes slow, that is called denser medium. Okay, light is moving fast, rarer medium. Light is moving slow, denser medium. So remember what is rarer, what is denser means. Rarer means moving very fast, moving very fast. Okay, if I'm take air or if I'm taking glass, where the light go fast, where the light will go fast, in air or glass? Air na. So air is a rarer medium. And glass, what about a glass? Glass is the denser medium. Okay. So why light goes slow in that particular denser medium? Because of the molecules or atoms. Okay. So whenever light travel from rarer to denser, here light traveling from air to water. Air is a rarer medium. Water is the denser medium. See, when it is entering light from rarer to denser, the ray the ray towards the normal, the ray towards, this is the actual direction, this is the actual direction of light ray. But what happened, it is acting towards the normal. Okay, here it is bending now. This bending property we called, this bending property we called refraction. A bending property is called refraction. So refraction depends upon what? It depends upon the nature of the medium. So which medium you are taking? Either it is solid medium. In a solid we have a types. You take in plastic or paper or glass. So it depends upon that particular material. Okay. Here you understand now what is mean by refraction. Okay. Next. See, laws of refraction. What are the laws are there? If you are applying a refraction, the refraction takes place. What are the laws are there in the refraction process? Here we have two laws. Okay, look at the first law, incident ray. So incident ray means the ray towards the surface. If you take this is the surface. Okay, towards the surface is incident ray, and refracted ray, where the refracted ray takes place in a second medium. In second medium, this is the actual ray, this is the actual light ray, okay, and it is acting towards the surface. This is called refracted ray, refracted ray, okay. And in first medium, which is this incident ray, how can you identify which is incident, which is refracted? Incident ray means towards the surface. See, direction is like this, towards the surface, okay, and this is the actual direction, this is the actual direction, but whenever it is changing a medium, it is towards the normal, okay. This is the refracted ray. And normal, and normal, incident ray, refracted ray, normal, these all are lies in a same plane. This is the first law of refraction. What is the first law of refraction? Incident ray, normal, refracted ray, all lies in a same plane, okay. You can remember with a shortcut also, rin, refracted ray, incident ray, normal, these three lies in a same plane, okay. Next, coming to the second law of refraction, this is very important for for numericals or conceptual also, okay. What is the second law of refraction? See, for a given pair of medium, which pair we taken? Medium 1, medium 2, it's a combination, it's a pair of medium, okay. The pair of medium, the ratio of sin I by sin r is equal to constant. What is the second law of refraction, ma? The ratio of sin I, sin I is nothing but what? Here the incident ray makes an angle with the normal, that is called incident angle. The refracted ray, which is in the second medium, this refracted ray also making an angle with the normal, that is refracted ray, okay. So here we take sine angle, sin I, here also we will take sine angle, sin r. The ratio of these two, the ratio of these two, we call it is that constant. The ratio of sin I by sin r is equal to constant, okay. This formula, this one is proposed by the Snell's law, that's why it is called Snell's law, okay. This one is proposed by Snell, that's why it is called Snell's law, okay. Remember that what is the Snell's law? What is the Snell's law? The ratio of, okay, the ratio of incident angle by refracted angle, sin I by sin r, sin I by sin r is constant. This law we call as that Snell's law, okay. Now we take in a constant na. Now we take in a constant na. What constant? The ratio of sin I by sin r, we call it is that refractive index. Remember the name, refractive index. So what is the use of this refractive index? Why? For example, here we take in air to another medium, it is internal light. How much bending takes place? How much bending takes place? Who will give? Refractive index will give, okay. Whenever a light changing from one medium to another medium, you will get the ratio of sin I by sin r na. The value you will get na, sin I by sin r value you will get na, that is called refractive index. This refractive index is decide how much bending takes place. This much bending or this much bending or this much bending, who will decide? Refractive index, okay. Okay, now see, refractive index is nothing but it is the speed of light in two media. Okay, two media. Why it is in two media? In one medium, the refraction cannot takes place. Refraction is nothing but what? Whenever light changing from medium 1 to medium 2, two mediums are required. If it is one medium, there is no refraction. Okay, for refraction, two mediums are required. Next point, it indicates that change in direction of light. Changing direction of light. See here how the direction will be. This is the actual direction of light ray. When there is only one medium, this is the actual direction. But whenever it is entering another medium, what changes? What changes? direction only changes. Direction changes, okay, and speed changes, okay, speed changes, direction changes. What it is constant? Frequency is constant. Remember, frequency is constant whenever a light changes from one medium to, whenever light travel from one medium to another medium, what is constant? Frequency is constant. What changes? Velocity changes, direction changes, displacement changes. These all are changes. What is the constant? Frequency is constant. Okay. Next, light travel fastest in vacuum. Light travel very fast in vacuum. Why? Why light travel this much fast in vacuum? Because here space, nothing is present. In space, nothing is present, no molecules or no atoms. That's why it is traveling this much fast. Okay. Speed of light in vacuum is how much? 3 into 10 to the power of 8 meter per second. Okay. And slow in air, glass and water. Why it is slow in glass and water? Because of, we already decided that it depends upon the nature of the material. If material changes, speed also changes. Okay. Next, if you take two mediums, okay, if you take two mediums, whenever light traveling from medium 1 to medium 2, medium 1 to medium 2, here we calculating that refractive index of second medium with respect to first medium. For example, in classroom you get marks, okay, you comparing with your friends na, how many marks you scored, whether higher or low. Okay, how you takes place comparison? Even your parents asking also, how many marks you scored? I scored much marks than my friend. You say like that now. So here also the comparison takes place. The comparison, the refractive index of the second medium with respect to first. Okay, the refractive index of the second medium. Okay, medium 2 with respect to 1. So how can we calculate that ratio? Speed of the light in medium 1 by speed of the light in medium 2. Okay, how can you calculate the refractive index of second material? I am getting good marks in physics compared to my friend because I am following that EdEasy classes. Here comparison is there na. Okay, so here also the second medium refracting with respect to first medium. How can we calculate the refractive index of the second medium with respect to first? Speed of the light in medium 1 by speed of the light in medium 2. Okay, and coming to that, if the same thing, if light travel from 2 to 1, if light travel from 2 to 1, what will happen? 1 to 2 we taken the refractive index of second material with respect to first. And here the refractive index of first material with respect to second one. Okay, how can we calculate? Similarly, speed of light in medium 2 by speed of light in medium 1. Okay, see here we take it two mediums, medium 1 and medium 2. Where to where light traveling? Where to where traveling? From first medium to second medium, the light is traveling. For example, I would like to calculate the refractive index of second material. Which formula I have to take? Tell me, anybody from the comment section. I need second refractive index of the second material with respect to first. Anybody from the comment section? Anybody from live? Second material refractive index is required. Second material refractive index. Okay, my marks are required comparing with respect to my friend. How many marks I scored? If my friend compare with me, that is also refractive index of that particular person with respect to me. Clear? Okay. So see, light traveling from first medium to second medium. Okay. If I would like to calculate the refractive index of the second medium with respect to first, then I will write refractive index of second medium with respect to 1. That is equal to speed of light in medium 2 by speed of light in medium 1. Okay, if you take 1 to 2, 1 to 2, 1 to 2, reverse, invert speed of light in medium 1 by speed of light in medium 2. Okay, if you calculate, if you multiply these two, speed of 2 with respect to 1, speed of 1 with respect to 2, what you will get? You will get 1. It's a inverse. It is inverse. Okay, clear na? Okay na? So if you want to calculate that refractive index of any material, means what we have to do? Compare with other material. Okay, I would like to calculate. Okay, I am saying that my marks are more. How should I know? I comparing with other, right? So here also the same thing. Okay, next, for light traveling from air to medium, where to where light traveling? Where to where light traveling? Light traveling from air to medium. Okay, air to medium it is traveling. So what is C here? C is the speed of light in air and V is the medium. Okay, speed of light in medium. C is what? Speed of light. Okay, we take now medium 1 by medium 2. If you want to find out refractive index of medium, means how can we take refractive index of medium? Means how can we take refractive index of speed of light in air by speed of light in medium? So refractive index of medium with respect to air, okay, speed of light in air by speed of light in medium. Okay, air speed of light we taken as C, medium we taken it as V only. Clear? Clear? Refractive index of medium, if you want to find out, means speed of light in air by speed of light in medium. Okay, next one. Look at here, activity. Activity, what activity is this? What activity is this? Refraction of light through a rectangular glass slab. Okay, which one we taken here? Which one we taken here? Rectangular glass slab. Okay, see here. See here, like this will be rectangular glass slab we take it here. Okay, so activity, look at the activity, what happened here? First light entering. Okay, let us take into two surfaces. This is the surface 1 and this is the surface 2. If you compare the first and second surfaces, how the two surfaces will be? Both are parallel each other, right? First surface and second surface both are parallel each other. Okay, look at 1, 2, how these two will be parallel each other. Where is the first surface? Above the first surface, air, and below the second surface also air only. Okay, so air to glass, rectangular glass slab na. So where to where it is entering? Air is one medium, glass is another medium. So light entering from air to glass. So here it takes place refraction 1. Here it takes place refraction 1. So why refraction 1 here? Air to glass, two different mediums. Whenever light travels in two different mediums, refraction takes place na. That only we discussed, right? When the refraction takes place, whether light changes its medium or not, you have to check that first. If you want to calculate the refraction, whether the light is changing a medium or not. Here medium changing or not? Yes, changing. Air is one medium, glass is another medium. Which is rarer? Which is denser? Tell me, anybody from comment section. Which is rarer? Which is denser? Yes, air is a rarer medium. Glass is the denser medium. Air is rarer. Glass is denser. Air is rarer. Glass is denser. So air to glass. What happened? This is the actual direction of light ray. This is the actual direction. See, the imaginary ray is there now. This is actual direction. If the glass slab is not there, how it will go? it go like this, straight line, because only one medium is present. Only one medium is present, it go straight line. Only one medium, because of one medium, it goes straight line. But glass slab is there na, it is second medium na. Whenever it is entering into second medium, what happened? Draw a normal, draw a normal, draw the normal. See, it is towards the normal. Look at that angle, this angle and this angle. See, see, this angle will be more na. This angle is more. See, this is the actual direction of light ray. But whenever it is entering into the another medium, towards the normal, towards the normal. Look at that, towards the normal. Okay, why it is towards the normal? Because light travel from rarer to denser. Remember, rarer to denser. When light travel from rarer to denser, how that light ray will be? Towards. Remember, towards. When light travel from rarer to denser, it is towards the normal. Okay, and look at here. Look at here. This is the incident ray, and the incident ray forms an incident angle that we taken as I1. And the refracted ray also making an angle with the normal, that is refracted angle. So I1, R1 are what? So I1 is incident angle, R1 is refraction angle. Okay, is completed? No. Again light ray traveling to the second surface of the glass slab also. In this case, see, glass slab to glass slab to glass slab to air. Again glass slab to air. See what happened here? What happened? Glass slab, denser medium, air, rarer medium. So in the second case, also refraction takes place. How many refractions are takes place here? Two refractions. Refraction 1 with the first surface, refraction 2 with the second surface. Refraction 1, air to glass. Refraction 2, glass to air. So glass is the denser medium. Glass is the denser medium. Air is the rarer medium. So denser to air it is travel. Denser to air it is travel. See, denser to air, incident angle, this is the incident angle, make an angle with the normal incident angle and extended the normal. Refracted ray also make an angle, refracted angle. So I2 R2 are what? I2 is the incident angle with the second surface, I2 is the incident angle with the second surface, and R2 is the refracted angle with the second surface. And look at that ray, look at the ray, away from the normal na, away from the normal na, towards the normal or away from the normal? Away from the normal. See, the actual direction is like this. But what happened? Away from the normal. Away from the normal. Why it is away? Because light travel from denser to rarer, it acts away from the normal. Clear? Rarer to denser. Remember the points I am writing here. Rarer to denser. Rarer to denser towards the normal. Rarer to denser towards the normal. Denser to rarer. Denser to rarer. How it will be? Away from the normal. Remember the points. Okay, if you want to calculate rarer to denser towards the normal, denser to rarer, away from the normal. Okay, how this light ray will be? This is the actual ray, right? This is the actual ray. And the emergent ray which is out, what we call that ray? Emergent ray. So how the emergent ray with the actual ray? Both are parallel na? See, if I draw that one normal, okay, one perpendicular line, how these two will be? How these two will be? Parallel. So it means if a light ray travel with the two parallel surface, the incident ray, the actual incident ray and emergent ray which is coming out, both are parallel each other. Clear? Okay. incident ray and emergent ray both are parallel each other. When the two surfaces are parallel, in this case only, okay, and it depends upon the incident angle also. Clear? Clear? See, the light ray at point O enter from rarer to denser medium, rarer to denser medium. How it will be? Bent towards the normal. We discussed that only, na? Rarer to denser towards the normal, denser to rarer away from the normal. Okay, denser to rarer away from the normal. How that emergent ray and the incident ray, how these two will be parallel each other. Emergent ray and incident ray both are parallel each other. Okay, and next one is that, see here, few materials refractive indexes are there. Okay, which one is having greater refractive index and which is having less refractive index, we have to observe these two, because in multiple times they will ask in examinations and that. Okay, which is the greater refractive index? We cannot remember all, but we can remember in classroom also who is the topper and who is getting less mark. These two only will identify. Okay, the rest of the students, they won't focus who is the topper and who is getting less marks. These two only in a classroom, right? Even in your class also will do the same thing, topper and slowness, so whatever the remaining and all, like the table only. Okay, see which is that highest refractive index. Look at that, where the highest refractive index, which material having? See, look at here, 2.42. which one? Diamond having more refractive index. Okay, diamond is the topper in refractive index. And which is less? And which is less? Look at that, which is less? Air is having less refractive index compared to other materials. Okay, so that's why the speed of light in air approximately we will take 3 into 10 to the power of 8 meter per second. Remember that? Remember that? Air refractive index and diamond refractive index. So what is the refractive index of diamond? 2.42. Refractive index of air 1.003. Approximately you can take it is 1. Okay, and the speed of light in air is that approximately we can take 3 into 10 to the power of 8 meter per second. Okay, can we go for next one? Yes. Now this time we have a problem. Okay, so don't worry about the problem. Okay, if you worry, the problem become problem only. Okay, so listen here, what is the given? What is the given information? The velocity of light in glass is 2 into 10 to the power of 8 meter per second. First of all, if any problem is given, write the given information. So from the problem, what is the given information? So the speed of light or velocity of light in glass is, velocity of light in glass. How much? They given it is 2 into 10 to the power of 8 meter per second. Okay, and then air, velocity of light in air. How much that is? 3 into 10 to the power of 8 meter per second. So two velocities are given. One time the light travels in air, that how much? 3 into 10 to the power of 8 meter per second. And the next time the velocity where that travel, it travel in glass. How much it is? 2 into 10 to the power of 8 meter per second. This is the given information. And the next, how much would an ink dot appear to be raised when covered by a glass plate of 6 centimeter thickness? Okay, if you take, okay, for example, I am taking this book. I am taking this book. There are few names right here. There are few names, right? So see how what is the distance between me and this? Let us take it is x. Okay, x distance is there between book and me. Book and me also x distance. With the letters also, how the distance will be? X only, no change, right? In between me and the book, if I will place a glass slab, how it will be? It appears like that the watts rises. Okay, if you see a coin under the water, how it will be? The coin is above the surface. It is appear like that, right? So here also, if the dot is there, see, here I am taking a glass slab and this is the surface. Okay, this is the surface. On the surface, ink mark is there. Glass slab we are using. Glass slab we are using. So what is the thickness of the glass slab? What is the thickness of the glass slab? 6 centimeter. So by using this 6 centimeter glass slab, how the ink appear will, let us take it is some point. Okay, I am taking this is the point x. From here to here, it rises x. Okay, so that x we are going to find out. So by using glass slab, how much distance it rises, that you are going to find out. Okay, so we taken all the given information. We taken speed of light in glass, okay, and speed of light in air also. What are we going to find out? What are we going to find out? Find out that how much when the covered by glass slab 6 centimeter thick, that how much would an ink dot appear. So how much height it appears, that we are going to find out. So first find out the refractive index of the glass slab. Because of this glass slab only na, it rises. If there is no glass slab, it will be appear how much distance there between the person to ink dot only. But when you using glass slab, how it is appearing? The ink dot is raised like that, it is appearing because of glass slab. So the glass slab refractive index you need to find out, because as per the refractive index only how much rises or how much fall down, it depends. Okay, so refractive index, what is the formula? Speed of light in air by speed of light in air by speed of light in medium. Okay, speed of light in air by speed of light in medium. So 10 to the power of 8, 10 to the power of 8 get cancelled. 3 by 2, 1.5. So the glass slab refractive index is 1.5 centimeter. 1.5 centimeter. But what we required? We required how much would an ink dot appear. Okay, what is the apparent position? What is the actual position is what? Actual position is what? 6 centimeter. Apparent position is what? That we don't know now. So by using glass slab, how much rises? How much rises? See, apparent position. Apparent position is equal to real height by refractive index. Real height is 6, refractive index is 1.5. Okay, real height is how much? 6 centimeter. 6 centimeter. So by the glass slab, what is the refractive index? Is 1.5. Then 1.5, 6, 4 centimeter. So this is the apparent position. Where it will be? Where it will be? Where it will be? It will be at 4 centimeter. Where it is the apparent position by using glass slab. If you without a glass slab 6 centimeter, by using glass slab how much it rises? 4 centimeter. So the normal position. If you are seeing like this, the normal position will be there now. Okay. So normal position. Normal. Okay. Normal is equal to real minus apparent. Real how much? 6 centimeter. Apparent is 4 centimeter. Then the normal is 2 centimeter. Okay. How much would an ink dot appear? 2 centimeter. Right. Okay. The apparent position is 4 centimeter. And glass slab thickness is 6. 6 minus 4. The normal we can see it is at 2 centimeter. Okay. Clear na? Clear? Can we go for next one? Next, write the given information for this question. Write the given information for this question. A ray of light. okay, is incident at an angle of 60 degrees. Okay, let us take okay, incident angle, how much it will be, how much it will be. Incident angle is 60 degrees. Incident angle is nothing but with the incident ray how much angle takes place. The normal, with the normal, how much angle takes place the incident ray. Okay, the incident ray takes place an angle with the normal, we call incident angle. How much from the question? 60 degrees on one face of a rectangular glass slab. So let us take rectangular glass slab. So this is the first face of the rectangular glass slab. So with the first face, how much angle? 60 degrees. And what is the thickness it is? So let us take the thickness is 0.1 meter. Okay, on the surface. 0.1 meter. And refractive index. So we no need to find out the refractive index. In problem only they give a refractive index. How much? Refractive index is 1.5. Okay, calculate the lateral shift. What is that? Calculate the lateral shift. See, lateral shift means what, ma? Here, what? Which are the parallel ray? Which are parallel here? Emergent ray, incident ray are there, right? This is the actual direction of the light ray. But what happened? Shifted to here, na? Okay, this is the actual direction of light ray, but shifted to here, na? This shifting we call as the lateral shift. Okay, here this is the actual direction, this is the actual direction. Okay, here to here it is shifted, right? So this shifting we call as the lateral shifting. Okay, so that lateral shifting we are going to find out here. What we are going to find out? Lateral shift L we are going to find. Okay, we have a formula on based on lateral shift. Lateral shift L is equal to T into sine of sin I minus sin R by cos R. This is the formula for lateral shift. Remember the formula? Lateral shift L is equal to T into sin I minus sin R by cos R. Okay. See, did we know sin I value? Sin I value we know how much? Incident angle only. Sin I is nothing but incident angle only. So sin 60, that we know. Okay. Next, we know sin R. We don't know sin R. But how can we find out sin R? How can we find out sin R? Is there any relation between sin I and sin R? Okay. Is there any other information is given? We have information. We have information. Refractive index also given, na? Given refractive index also, right? So refractive index sin I, sin R. What is the value we have? By using these three, refractive index, sin I, sin R. Is there, do you remember any formula? Anybody from the comment section or chat box? Anybody? Anybody? Yes, Snell's law. What we call it is that Snell's law. Okay. So what is the Snell's law? What is the Snell's law? Constant. The refractive index n is equal to sin I by sin R, na? That only in the formula. That only anybody from the comment section. This only in the formula. Yes, this only the formula. Okay, sin I. So we know sin I and refractive index also we know. Which one we don't know? Sin R we don't know. Then sin R is equal to sin I by refractive index. So sin I value. So sin 60 value 0.85. Okay, and refractive index value. Refractive index value how much they given? 1.5. That only na refractive index. That only na 1.5 only na they given. So if you are calculating how much value you get, 1.5 by 0.8. Let us take it is 9 approximately. 0.6 will come na. 0.6. So 1.5, 0.85. So 0.57. 0.587 is what, ma? Sin R. That only na 0.57 only na sin r. Then r is equal to sin inverse of 0.57. That only na, anybody from comment section? That only na, sin r is equal to 0.57. Then find out the value of r. Find out the value of r. R value is equal to 35.2 degrees. Okay, what is the refraction angle? See, air, rarer medium, entering into the glass, denser medium, how it will be? Anybody, this is the actual direction of light ray. This is the actual direction of light ray. Anybody from the comment section? Anybody? Anybody? Anybody from the comment section? How it will be when light travel from air to denser medium? Towards or away? Towards or away? Anybody? Towards or away? Okay, denser na? Towards the normal. So this is the refraction angle. Okay, how much the refraction angle? 35.2 degrees. So we know all the values na? By using lateral shift formula, T we know 0.1, sin I 0.85 minus sin R 35.2, cos R also 35.2 only. So substitute all the values. Substitute all the values. L is equal to T value 0.1, sin I value 0.85, sin R value sin of 0.85, sin of 0.85, sin of 0.85, sin of 0.85, sin of 0.85 minus sin or sin of 35.2. Okay, by what is the formula? Cos r, by cos r. R value cos of 35.2 degrees. Okay, so substitute the all the values. What they given? T value is given 0.1, we substituted. Sin A value sin 60 we taken. Okay, 0.85, and we substituted sin R value 0.57. Okay, sin 60, sin 60, let's directly substitute the value. Sin 60, sin 60, okay, minus, or else the value is also same one, sin 60 0.85 na, sin 60 0.85 na. Substitute those values only. Substitute those values only. 0.85 minus sin R value, sin of 35.2. Okay, so approximately how much value we get it here? Approximately the lateral shift value will be, how much will be? How much will be? Approximately you will get 5.1 centimeter. Okay, this is the formula for value of lateral shift. So how much shifted ma? See, this is the actual direction. Again light ray entering here. Okay, draw the normal. This is second incident angle, I2, normal 2A na. This is the actual ray, right? So how much displacement takes place between these two? How much displacement will take place? So this displacement only na we call L. How much will be? 5.1 centimeter. How much will be? 5.1 centimeter. Clear? Next, spherical lens. What is the next topic? Next topic, spherical lenses. Lens is a transparent material. Okay, lens is the transparent material. Lens is a transparent material. We can see with the help of lenses only na. If anybody having any defect means with the help of lenses only we can see. How many faces it has? Two surfaces it has. Let us take, I am taking a biconvex lens. This is also one reflecting surface. This is also another reflecting surface. Okay, where it will be uses in spectacles, glasses, and magnifying glasses. If you see that telescope, okay, and microscope, we will use these lenses. Okay, next, if lens has only one spherical surface, The other surface will be plane surface. Remember the point. Okay. One circle surface. That means if I'm taken into two parts here, this is the first part and second part is removed. Then how it will be remaining all are plane only na? Plane only na? Okay. Next. Look at that. Convex lens. Okay. A double convex lens has two spherical surfaces bulging outward. Look at the diagram. Look at the diagram. How it will be two reflecting surfaces. If anybody having any question based on this biconvex lens, having any doubt, I am getting one doubt here. You also get the same doubt. See, if you take a mirror, how many focuses are there? One focus is there. But here, see, how many focuses are there? F1, F1, 2F1, 2F2. Two focuses are there in each side. Each side, two focuses are there. F1, F2 are there. Why it is two focuses? Why it takes place only one focus and mirror? You are also get the same doubt now from the chat box. You are also getting the same doubt or not? Yes or no? Obviously, you will get doubt. Mirror having only one, but lens having two focuses. How it will be? Why it is? Because here the answer is how many reflecting surfaces are there? How many? Tell me. How many surfaces are there? Two reflecting surfaces are there. Because of these two focuses will be clear. Okay, if you have to ask your friends also, why lens is having two surfaces, two focus, the answer is that two reflecting surfaces are there. Okay, next, how it will be thicker at the center, okay, and converge parallel. See, it coming from infinity, where it meets, where it where it meet after traveling through the lens, it meet at one point that we call focus. Okay, converging. Which lens it is that? Converging lens. Why it is converging? Combining at a point. Remember, there concave mirror is converging. Here, convex lens is converging. Clear? Concave mirror, convex lens. Both are same. Both are having same property. That properties we will discuss further. Concave mirror, combining at a point. Convex lens, that is also combining at a point. Okay? Okay, see. Double concave lens. Previously, double convex lens. Okay, double concave lens. So here, this double concave lens having a property of convex mirror. Convex mirror. Here, convex lens is having a property of concave mirror. Remember, to remember easily, convex lens, convex lens is concave mirror properties are there. Okay, concave lens, convex mirror properties are quite opposite. Okay, see, double concave lens has two spherical surfaces curved inward. There curved outward, here curved inward. That is the difference. Curved inward, curved outward. Thicker at the edges, and it will be divergent because convex mirror, it is a diverging mirror only. It is a diverging mirror. Here, concave lens, diverging lens. Same like convex mirror. Okay. Okay. Next, a ray parallel to the principal axis. Tell me, we already discussed in session 1. We already discussed in session 1. Okay. If any ray parallel, how it will be? Meet at a focus. Meet at a focus. That we know na. If any light ray parallel. Look at the diagram. Where it started infinity. How this with the principal axis parallelly. Where it is meet at focus. Whether it is concave or convex. Either it is concave or convex lens. If the light rays or infinity or parallel to the principal axis. The first property, okay, first property, parallel means meet at a focus. Clear? Next, next, light ray passing through the principal focus. Light ray passing through the principal focus. First point is what? Parallel means meet at a focus. And passing through the focus, passing through the focus, it will be parallel to the principal axis. Na? Quite opposite. Na? We already, how we discussed in a mirrors, the same thing here also going. Okay, there concave mirror, here convex lens. Clear? So, parallel to principal axis, meet at focus. Passing through the focus, meet a parallel to the principal axis. Clear? Next, look at that. Look at that. Passing through optical center. See, this is the optical center of the lens. Passing. No divergence takes place. No deviation takes place. No conversion takes place. Okay. Whatever the lens passing through optical center, no deviations. There also in plane mirror also the same thing. Passing through normal, deviated 180 degrees. Here there is no deviation takes place. If passing through the optical center, no deviation. See, any deviations have you seen? No deviations are occur when light passing through optical center. Remember, if a light ray passing through optical center, no deviations are. Okay. Remember, no deviations when it is possible. If light ray passing through optical center passes through the lens, no deviation. Okay. Next, so have a break. I hope you all are tried. Okay, have a 5 minutes break. Again, after 5 minutes, we will meet with the same energy and same joy. Okay, have a break, all of you. Okay, so can we start our section without any delay? Okay, chill. See, you have to identify that where is the object and where the image takes place. We have to see, you have to identify the differences, whether it is lens or mirror. You have to focus on only one thing. Where is the object position and where is the image position? You have to see these two things only. Okay, so where is the object and where is the image? Compare object position is where and image position where it is exactly. Okay, so here we take in object at infinity. Okay, blindly follow. If object is at infinity, where is the position? Anybody from the comment section? Anybody? Where is the image? F. F. Okay. So which mirror, which lens we are taken here? Convex lens, na? Convex lens. So the convex lens properties, how it will be? It's similar like concave mirror. Okay, the properties of concave mirror and convex lens are similar. Object at infinity, image at f only. Okay, and coming to the sign convention, what is the u value? U is object, v is image, f is focal length, na? So object distance always negative. Okay, u is always negative. Can you guess why v is positive? Anybody? Anybody? If you know sign conventions, why v is positive? Why v is positive? And there in concave mirror, v also negative. But in convex lens, what about v? V taken positive. Anybody can give the reason from comment section. Also give reason why V is positive in convex lens. Why V is positive? Because see, this is the direction of incident ray. Along the direction of incident ray, what is that? Positive only, na? Opposite to the incident ray, negative. Along the direction of incident ray, positive. Remember, opposite to the direction, negative. Along the direction, positive. That's why V is positive. And F also positive only. F also along the direction, na? That's why F also positive. Okay, so V and F are always positive except one case. That one case, what it is, we will discuss later. Okay, in this only. Next, and what about that nature? What about the nature? It's very important. You should know about the nature also. Which mirror? Concave mirror. We comparing with the convex lens. What we discussed, both are same properties, similar properties. Okay, real, real only. How the image will be inverted, inverted, and size highly diminished. Okay, compare, just comparison with the mirror and lens. If you are going for concave mirror, go for convex lens. Both are similar only. Okay, go for concave mirror, go with the convex lens. Convex mirror, concave lens. Okay, next, tell me, where is the object between infinity and 2f? See, where is the object between infinity and 2f? Where is the image takes place? Between f and 2f. Infinity and object. Beyond C, between P and C. So here also between f and 2f, how the images will be real, inverted, diminished, like concave mirror blindly follow. Like concave mirror. See, at f, at 2f, at 2f, there also at C, it's C only. Okay, it's C. Here 2f, 2f. Coming to this point, coming to last three, quite opposite, inverse, inverse. Okay, see, infinity, f. If it is f, where it will be infinity only, na? At f, infinity. The object at infinity, image at f. Image at f. Okay. Now see, object at f, image will be infinity, quite opposite. Okay. Between f and o, where is the object? Where is the object? Between optical center and f. See, optical center and f. Where the image will be? Where the image will be? On the same side of the lens. In this case, except in this case, all the cases are real image only. In which case, in concave mirror also, if object takes place between pole and focus, okay, pole is the optical center, f is the focal length, in between these two object is there. So here also the same thing, optical center and f, between these two object is there. What is the image will be? Virtual image. There also behind the screen, na? Here same side it is. Okay, same side, there it is behind the screen comparison. Here it is same side, in the mirror opposite side. Okay, behind the mirror, which type of image? Virtual, erect, enlarged. Same properties like concave mirror. If you remember concave mirror, you understand about the convex lens. Same, no changes at all. Okay, only changes takes place in sign conventions. There B positive, F also positive. There all are negative except in one case. Okay. Next, coming to the concave lens. Okay, concave lens. Concave lens is a convex mirror property. Okay, remember convex mirror property. At F, at infinity, at F only similar. Look at that. Where the light rays are coming from infinity, where it is meet, where it is meet, where it is meet, where it is meet, it meet f no virtual, right? Okay, and look at the sign conventions. U negative, V negative, F also negative. Okay, F also negative. U negative, V negative, F also negative only. Okay, there U only negative, V, F are positive. Clear? Next, coming to the second point, where is the object between optical center and infinity? Okay, between infinity and optical center, where is the image takes place? Where is the image takes place? Image takes place between O and F. There also same na, object at infinity, where the image takes place between P and F. Here O and F. The difference is what? There P, here it is O. That's it. Okay. F and O, virtual, erect, diminished, same thing only. Okay. No need to study about a lens if you understand the mirror, concave mirror and convex mirror properties similar like convex lens, concave lens. Convex lens, concave mirror, both are properties are same except sign convention. Concave lens, convex mirror, same properties are except sign convention. Okay, remember. Next, look at the sign convention. Along the direction positive, opposite to the direction negative, above the principal axis positive, below the principal axis negative. Okay, above the principal axis positive, height coming to the heights only, coming to the height only, you have to check above or below. Above means positive, below means negative. Along the direction of incident ray positive, opposite to the direction of incident ray negative. Remember. Okay, this is for convex lens. And coming to here, coming to along the direction positive only, opposite to the direction negative only, above the principal axis positive, below the principal axis negative. Okay, the sign conventions are same. Along the direction positive, opposite to the direction negative, above the height positive, below the height negative. Clear? Okay. Next, coming to the lens formula and magnification. Lens formula and magnification. So we know mirror formula, right? What is the mirror formula? I'm comparing. See, here I'm reminding that mirror as well as lens. Okay, because in the past section you forget about mirror. Okay, now I'm revising that mirror formula. So 1 by f is equal to 1 by v plus 1 by u. See, this is a mirror formula. Mirror formula. And this is the lens. Compare both. Compare both. Anybody from comment section, compare both lens and mirror. Which is changes? Okay. Is there any difference in that? Is there any difference in mirror and lens? What difference is there? In lens you have minus. In mirror you have plus. That's it. Okay. Y minus, Y plus. Object and image as per sign conventions negative. Here object is negative, image is positive. Clear? Okay. Next, it's valid for all spherical lenses. The formula is valid for all spherical. There it is valid for all spherical mirrors. Here it is valid for all spherical lenses. Next, coming to the magnification. What is the use of magnification? How the image will be compared to object size, how the image will be. Whether it is small or whether it is more with respect to the size of the object. Okay, so you need to find out the magnification means how the image will be compared to the object. Same object, if I see, okay, through the mirror or through the lens, how it will be very small or very big, you have to see. Okay, microscope is there. What is the purpose? We can see that image will be very large and compared to the object. Okay, if I am seeing this object, it will be very huge. Image will be. So, how the magnification will be compared to the object size, how the image will be. Magnification is nothing but it's only about image with respect to an object. Okay, see here V by U. There will be, if you take a mirror, in mirror we will take minus V by U. Remember, I am explaining both at a time. If you take mirror formula, minus v by u. In the lens, v by u only. And heights, hi by h naught, that is similar only. Okay, height of the image by height of the object for magnification. Look at the formula. Look at the question. An object of 5 centimeter is placed 20 centimeter away from converging lens. They not mention which lens given. We know concave lens. We know convex lens. We know concave lens. We know. But what they said? Did they mention the two names? Convex lens and concave lens? No, they not mention. But they given a hint na. Which lens it is? Converging lens. So converging lens means which lens? They given a hint. Which lens? Converging lens means which lens ma? Convex lens. By seeing the diagram you may know it. Which lens it is? Okay, which lens it is? That convex lens. Okay, so an object 5 centimeter. Okay, 5 centimeter object, height of the object is 5 centimeter, placed 20 centimeter from a converging lens. So from the optical center, what is the object distance? 20 centimeter from the optical center. Okay, next, focal length of the lens is given. So focal length is how much ma? Plus 10 centimeter, because towards the incident ray direction na, focal length will be plus 10 centimeter. Object distance is minus 20 centimeter. Okay, what we need to find out? Find the position. So position means where it is. V value we are going to find out. V. So which formula we take? Lens formula only na. Anybody lens formula from comment section? Mirror formula 1 by f is equal to 1 by v plus 1 by u. That we know. Lens formula 1 by f is equal to 1 by v minus 1 by u na. So 1 by f value, focal length value how much they given ma? Focal length is 10 centimeter. 1 by plus 10 is equal to 1 by v minus object distance minus 20 centimeter. Substitute minus 20 centimeter, minus into minus, plus 1 by 20. If it will come this side, 1 by 10 minus 1 by 20, that is equal to 1 by v. Guess the answer. What is the image will be? Anybody from comment section, what is the image will be? Take LCM. 2 minus 1. 1 by 20 na. So V is equal to plus 20 centimeter. Can you guess, anybody from comment section, why V value is plus 20? Anybody from comment section, why V value is plus 20? Anybody from live, why V value is plus 20? Because where the image will be, if object is 20 centimeter, that means image also 20 centimeter only na. Image also 20 centimeter only na. So image distance also 20 centimeter. That means object distance is equal to image distance. It means where is the object? At where is the object? At center. Center of curvature, how it will be? See here also 2f1 is equal to 2f2. 2f1 is equal to 2f2. The problem is solved? No. We have just find out the position. And size. We're going to find out the size. What is the size? Huh? Magnification. Who will tell? Magnification. Formula for magnification. V by U. Remember. V by U. V value plus 20. U value minus 20. Then it will be minus 1. So magnification value is that minus 1 centimeter. But why are we going to find out? Size. Okay. Which one size? Image size. So what is the formula? M is equal to height of the image by height of the object. So magnification value minus 1. height of the image we don't know, height of the object they given 5, then height of the image. So height of the image is equal to minus 5 centimeter, height of the image. So you will get in height minus, it means inverted, it means inverted, okay, it means inverted image, okay. Below the principal axis, now this is the principal axis, right? This is the principal axis. So below the principal axis, 5 centimeter height, 5 centimeter height. Below the principal axis is what? Minus 5 centimeter. Okay, minus 5 centimeter. So height of the image is minus centimeter. Next, nature of the image, real. Nature of the image, real and inverted. Same size. Okay, because it object distance is equal to image distance. 2f1 is equal to 2f2. Same size. Nature of the image, real and inverted. Okay. Yeah. Can we go for next one? Yes. Next, power of a lens. Power. Okay. So if you have any power, how can you show me that power? Okay. If you have any work, by doing that work, how much time you are taking? That is the power calculation, right? Work done per unit time. That is the power. But here, who is having a power? Lens is having a power. Okay, who is having power? Lens is having a power. How can you find out that power of a lens? If a human being power means, how can we calculate? By lifting the objects. Okay, by lifting the object heavily, then show that power. Okay, or pulling a vehicles, or doing a work, how much fast he is doing a work. Okay, so there we calculate a power like that, work done per unit time. That is a general formula for find outing a power. But here, which power we want? Lens power. So here also we have a formula, but not work done by time. Okay, so power is equal to the reciprocal of focal length. 1 by f is the formula of power. What is meant by power? Ability of a lens to converge or diverge light rays. Okay, how ability it is there? How ability it is there? Converging and diverging. Okay, so if you're in your friends having experts are there, right? Okay, experts means if there is a fight means few people will combine. So they having ability to combine those two people, and few people having a ability to separate also. Okay, so for combining how much power it is there, for separating how much power it is there. Okay, so here also we have a two lens, convex lens we have, concave lens we have. So convex lens combining, for combining how much power it is required. Here you combining your two friends na, for you also required power. Here also, here also I am taking convex lens is there, for combining, for combining, for combining, for combining, power is required. How much power is required? How can you calculate? It's based upon the focal length. The ability of combining or diverging is called power of a lens. So the formula power of lens is equal to 1 by f. It's completely depends on focal length only. See, if focal length is increases, here there is some technical issue. We are back again. Okay, so again check the power of lens. So what is mean by the power of lens? What is mean by power of lens? So what is the use of a power of lens? Okay, so if you're taking a lens now, if you're taking a lens means how you calculate that power of lens. So what is, first of all, what is mean by the power of lens? How combining a light rays, okay, how diverging a light rays through a lens. Okay, for example, if I'm taking a convex lens, how the light rays are combining through that lens? What is the power? How much it will be? How many light rays are combining? Okay, for example, if someone is going through the through back, I will stop. Okay, how many are stopping? That is my power. Okay, see here also, if I'm taking a convex lens, how many light rays are combining by this? Okay, how many light rays are combining by this? How many light rays are by combining this? If I'm taking one more, it will be different na. So this is having one power. Okay, this is having one power. So how can you calculate the power of that? Okay, how it is combining or how it is diverging? Based on that, we will calculate a power. So especially the power depends on focal length. Especially the power depends on the focal length of the lens. Okay, so that unit, SI unit, remember the SI unit of the power is diopter. Okay, what is the SI unit? Pronounce with me, diopter. Okay, diopter. And the focal length will take in meters only. The focal length we always take in meters. So P is equal to 1 by m meter. So 1 by meter, what we call diopter. Okay, diopter. Diopter. Okay, yeah. Next, look at the problem. Two lenses, one of the focal length is 20 centimeter, so f1 is equal to 20 centimeter. So did they mention which lens it is? Convex lens. For the convex lens, what is the f1 value? 20 centimeter. Okay, and another focal length is minus 15 centimeter. So they only given sign convention. Which lens it is? F2. F2 minus 15 centimeter. With the sign convention, they given a values. F1 is 20. That means plus 20. Which lens it is? That convex lens. Okay. And one more is that concave lens. That sign convention also, they only given the value. Minus 15 centimeter or placed in contact. Okay. How these two will be? One convex lens with the focus of 20 centimeter and another one will be concave lens. Both are in contact. Optical center O. O. Okay, both are placed in contact. What is the focal length and power of the accommodation? So focal length of which one? This is having a one focal length, that is f1, and concave also having focal length f2. So the combination of these two, we call it is that focal length. Okay, 1 by f is equal to 1 by f1 plus 1 by f2. 1 by f1 value, f1 is what? 1 by plus 20. F2 value minus 1 by 15. Take LCM. 20, 50 LCM. Anybody from the comment section? Anybody from the comment section? LCM for 20 and 15. LCM. Anybody? How much? LCM 20 and 15. 16. How many times? 3 times. And here 4 times. 3 minus 4 minus 1 by 16. 1 by f is equal to minus 1 by 16. Minus you will get. For which one? For which one? For which one you will get minus focal length ma? Negative. Where you will get? Concave lens you will get negative. Concave lens you will get negative sign convention. Convex lens is always positive. Is it na? Is it na? Right? So F value how much? F value is minus 60. Combination of focal length is that minus 60 centimeter. The problem is over. No. Just we find out focal length only. Next, which one we are going to find out? Anybody from comment section? Anybody? 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 What we going to find out? Power. What are we going to find out? Power of this combined. Power of the combined, right? So power P. Tell me, power depends upon which one? Anybody from comment section or anybody? Power depends on what? Power depends on 1 by F only na. Yes, right? Power depends on 1 by F only. What is the combination of the focal length ma? 100 by focal length. How much value? 60 minus 60. How much value you will get? 0, 0. How much value? 10 by 6. 0, 0 cancel na. 10 by 6 you will get. Means how many times? 10, 6 mein. 1 times. Remaining 4 is there. Right? 1.6 is the 1.6 diopter. Minus 1.6 diopter is the power of the combination of concave and convex lens. Clear? Clear? Remember na? Power is equal to 1 by f. That is the formula to find out the power of the lens. Clear? Next. Yeah. We came to end of the section. What you learned in the section, once again recapitulate very quickly. Okay. Introduction of refraction. Introduction. Refraction, when it takes place, very simple. Anybody from comment section, refraction means what? Refraction means what? Bending. Simply refraction means bending. When it takes place with the one medium, is it possible bending? No. Two mediums are required for bending. Two mediums are required. Either 1 to 2 it travel or 2 to 1 it is travel. Okay. Laws of refraction. Laws of refraction. Incident ray, refracted ray, normal lies in the same plane. That is laws of refraction. And one more laws of refraction. Very important one is what? Snell's law. Snell's law. Remember na? Snell's law. Ratio of sin I by sin R is equal to constant. Sin I by sin R is equal to constant. This constant we called refractive index. That refractive index only will decide how much bending or how much not bending. Okay, away from the normal or towards the normal. Okay, towards the normal or away from the normal. Who will decide? Refractive index will decide. Clear? Clear? Next, refraction by spherical lenses. How many lenses are there? Convex lens is there. Convex lens is there. Concave lens is there. Okay. So convex lens properties are just like concave mirror. And concave lens properties are just like convex mirror. If you remember the concave mirror and convex mirror, lens are easy. Okay. Next, lens formula. Lens formula. 1 by f is equal to 1 by b plus or minus 1 by u. If you take a mirror, this is for lens. If you take a mirror formula, plus will come. This is the mirror formula. Okay, at a time I am giving two, lens and as well as mirror. Don't confuse. If you take mirror, plus will come. If you take lens, minus will come. Okay. Next, power of lens. What is the power? What is the power of the lens? How combination power, diverging power. Combination power, diverging power. Combining power, diverging power. Okay, if two friends are fight, what you will do? Combine. You have a ability to do that. Okay, that is a power. Combination power and diverging power. If you want to separate, for that also you need power. Okay, combination power, diverging power. So power of lens. What is the unit, ma? Diopter. Okay, what is the unit? Diopter. And power of lens mainly depends on focal length of the lens. Clear? I hope you all enjoy that section. Okay, enjoy the section. Yes. Okay, I am also enjoy with you. Okay, these sections will be continue like this only. Don't miss any classes. Okay, I hope you all are enjoy the section. Okay, yeah. Thank you all of you. We'll meet you again in the next section. Thank you.